Happy Thursday, happy Thursday, happy Thursday. We're going to start on page 47, and this is the page that we're going to do today. Tomorrow we're going to do 48 A, B, and C. So you're going to do 47 today. You have an exit ticket and a partner activity and a homework sheet. You should be able to get it done. Don't worry. Don't stress. Alright, so I want you to go to this page. I want you to write down these two learning targets, and we're going to use this for 47 and 48. So the first learning target that we're going to cover says, I can use proportional parts within triangles. The second learning target that we're going to cover, I can use proportional parts with parallel lines. And we're going to take it one flappy at a time. Now, you pause it whenever you need to. If you're watching this on your headphones, pause it as you go. If you're watching it on the big screen, have Raven pause it if you're second period, and seventh period, the sub will help you and pause it. Okay? You just have to speak up. Now, triangle proportionality theorem. That's the first one that we're going to talk about. It says, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. No, it says the converse is also true. That's just if you flip it around. So that means that if these two lines right here are parallel, so if AB, segment AB, is parallel to segment CD, then your sides are proportional. So let's start at the bottom. AC. What side does that match up with? Well, it matches up with CE because they're on the same side. So AC divided by CE equals, start at the bottom, go to the top. That's it. That's all you have to do. If they're parallel, the sides are proportional. And it divides the two sides proportionally. So what it did was these two parallel lines cut that side right there into proportional parts so you can divide them. Same thing over here. It cut into proportional parts, divide them. Alright, let's open this and look inside at some problems. I'm going to move my pens out of the way. Alright, so it says find x. Now, are the sides parallel? Yes. So that means it cuts it into proportional parts. So we can make two fractions or two ratios and set them equal to each other. So we're going to do x, this side, divided by the top, equals 18, because that is across from x, divided by 27. Now, how would we solve this? Well, it's a proportion, and how do we solve proportions? We cross multiply. Alright, so you have 27 times x, which is 27x. And then you have 33 times 18, which is 594. Look at you guys go. And then we divide by 27, and x equals 22. Voila! If you need to pause it, pause it. If not, let's move on to the next one. Now, we can do this problem two ways, and I love this problem because it makes you think. Not only does it give you the whole side, but you can also find this part right here. And the way you can find that part is you can just subtract them. So it gives you that this half, or this, it's not a half, this portion right here is x, and the whole thing is 20. So this would be 20 minus x. Now, if you can't wrap your mind around that, let's do the whole thing. So we could do it 20 divided by x, because those two are on the same side, equals 16 divided by 12. Now, where did we get 16 from? Yep, we got it by adding 4 and 12 together. Or 20 minus x divided by x, this part right here, equals 4 divided by 12. So you can either do opposite sides, or you can do the whole thing. Either way works. Then you cross multiply, and you get 16x equals 240. Divided by 16, x equals 15. Voila! Pause it if you need to. Let's move on to parallel lines and transversals. Super exciting. Alright, this theorem says that if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. Okay, that's a lot of words. But what it means is that these 3 are parallel. Then it divides it into proportional sections. So you have this section right here. Is proportional to BC. So AB is proportional to BC, and DE is proportional to EF. That's it. So if, let's see, AD is parallel, that's this line, to BE, that's this line, which has to then be parallel to CF, whole lot of parallel lines. Then it cuts them into parts. So you do the same thing as we did in our triangles. These are on the same side, so they're proportional. It cuts it into proportional parts. So you just do AB divided by BC. And since we started with AB, we're going to start with DE. Ta-da! Ready to go inside our foldable. Let's do this, taters. Start with the one on the left. Okay. Now, we have 3 lines. Are they parallel? Yes, they are. And the reason we know they're parallel is because of those beautiful arrows. Now, if those 3 lines are parallel, then this top segment is cut into proportional parts. So we're going to do x divided by 12.5. And proportional just means you make a ratio. Equals, now if we started with x, what are we going to start with down here? 12. And how do we solve our proportion? We cross multiply. Ta-da! That's it. That's all you do. Ready to look at the other one, or do we need a mo? If you need a mo, pause it. Alright, let's look here. Now, these 3 lines are parallel. We're gonna assume that they are because we need to be able to find x. Now, I'm going to start with 18. Now, what side does 18 match up with? Matches up with 27. So 18 divided by 27 equals, yep, x divided by x plus 10. So if you start with 18, start with x. If you end with 27, end with x plus 10. Now, cross multiply. Forgot my parentheses. Got a little too excited. I know that some of us can go ahead and distribute that 18, but I really like to see this step just so we make sure that we're not missing any steps here. I don't want to make any mistakes due to basic errors. What would I do here? I would subtract 18 because this is a positive 18x and we need to get it over here, so subtract 18. And then divide, and x equals 20. Alright guys, almost ready for the last one of the day. Isn't it exciting? the triangle angle bisector theorem. Now, what is an angle bisector? An angle bisector cuts the angle in half. Now, and if it bisects the angle, that means that you have proportional parts of your triangle. So if a ray bisects an angle of a triangle, right here, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Now, what on earth does that mean? That means that if this bisects right here, then AD divided by DC would equal the sides divided by each other. So if BD bisects angle ABC, then AD, which is your bottom left, divided by DC equals AB divided by BC. Let that soak in, marinate. The bisects, you have proportional sides. Okay, let's look at our problem on the inside. Let's start over here on the left. Now, does it bisect this angle? Yes, it does. So that means that you set these two as proportional and these two as proportional. I don't know why it has tickies through the rainbow, but we're going to pretend like they didn't do that nonsense. All right, so you would do 8 divided by 10 equals x divided by 12.5. Now, did we create a proportion? We did. So all we have to do is what to solve it? Cross multiply. And then divide. Alright, let's go look at this one. And remember, pause wherever you need to. Now it bisects this angle, so we now have proportional sides, proportional sides. So we would set it up as x divided by 15 equals 10 divided by 20. Cross multiply. Divide. Use this to help you. Go back and rewatch the video if you need to. Hope you have a great day. Do your exit slip and your partner activity, and then do your homework sheet. Love you guys. Be good.